So okay, we have finished acid, carboxylic acids and their derivatives. Okay, so if you see this in depth, then they are very easy actually. You see, uh, this is formic acid. Okay, its common name is what? Formic acid, and its chloride is what? Formyl chloride. So formic acid, formyl chloride, and its anhydride is what? Formic anhydride, and its ester, the ester of formic acid, the name will end with formate. What? Formate. And its amide, the amide of formic acid is what? Formamide. And the last one, cyanide or nitrile, the nitrile of formic acid is formonitrile. You see, formic acid, from formic acid, these are all derived. That's why these are all, that is chloride, acid chlorides, acid anhydrides, esters, amides and cyanides are otherwise called as what? Derivatives of carboxylic acids. Okay, so like that acetic acid, acetyl chloride, acetic anhydride, methyl acetate, acetamide and acetonitrile. Okay, so all will have the name but acid actually. Okay, if it is the carboxylic acid, it is acetic acid, acetic acid. And if it is acid chloride, the acid chloride of acetic acid is acetyl instead of ICYL. So acetyl chloride. And its anhydride, acetic acid, and its anhydride is what? Acetic anhydride. And ester, the ester of acetic acid is acetate. The alkyl group will be, it may be anything, whether it is ethyl, methyl, like that. Okay, it may be anything, but if it is the ester of acetic acid now, then the name will end with acetate, acetic acid, acetate. Okay, and its amide is acetamide, and its nitrile, that is cyanide, and its nitrile is acetonitrile. Okay, so in this way you can easily memorize or you can easily understand. Don't memorize, it's easily you can understand all this. Okay, it will be interesting, it will be very much interesting. Okay, right. In aromatic part, in some books it may be differently given. For example, benzoic acid actually, okay, it's IUPAC name. In TN board, benzoic acid itself, NCERT also benzoic acid given, but benzene carboxylic acid is also correct. Okay, because let us see, benzene ring, if benzene ring contains one acid, carboxylic acid group, then it is called as benzoic acid. Okay, if the benzene ring contains two acid groups at ortho position, do you know, in benzene ring the angle between two substituents is 60 degree, then it is called as ortho. If the angle is 60 degree, then it is called as what? Ortho. Okay, right. The common name for this compound is phthalic acid, PHTHALIC, phthalic, not phthalic. Okay, you should read it as what? Phthalic, PH silent. Okay, phthalic acid. Okay, right. And its IUPAC name, what will be the IUPAC name of this phthalic acid is benzene 1,2. This is first number 1, this is number 2 position. Number 1 position, number 2 position. Or this one, if this one is number 1, then this one will be number 2. In any way you can give. Okay, so benzene 1,2 dicarboxylic acid. If acid group is directly present in the benzene ring, then this COH group is directly, as it is called as what? Carboxylic acid. So in the same way, for benzoic acid we can give what? Benzene carboxylic acid. Okay, and for phthalic acid it is benzene 1,2 dicarboxylic acid. Okay, right. If aliphatic, if it is aliphatic, for example COOH, okay, the common name for this compound is oxalic acid, ox. If two identical groups are there, then generally the name will have the word ox. Okay, being acid, so it is oxalic acid. Being acid is what? Oxalic acid. And its IUPAC name is, so it is aliphatic, so we have to give numbers to the carbon chain. So CC, 2 carbons, so ethane, what? Ethane, okay, 2 acid groups, so simply dioic acid, ethane, dioic acid, ethane, dioic acid. This is oxalic acid, okay. If one CH2 group is present between 2 acid groups, then the common name for this compound is malonic acid. The common name for this acid is what? Malonic acid. Malonic acid. Okay. Then its IUPAC name will be, so numbering 1, 2, 3. Or from here also you can start 1, 2, 3. So 3 carbons. So the IUPAC name. 3 carbons means what alkane? What is the root word? Prop. Only single bond between carbon atoms. So N. Propane. 1 and 3. The position of acid group is 1 and 3. So 1, 3 dioic acid. 1, 3 dioic acid. Okay. This E should not be removed because the incoming word has D, which is also consonant. E, this, okay, this is vowel, this is a consonant. Vowel will combine with consonant. If you remove this E, then what here the next letter will be? N. N is a consonant. D is also a consonant. Consonant will not combine. So, okay, that's why you should not remove what? E. So propane 1, 3 dioic acid is the IUPAC name for malonic acid. If 2 acid groups are present, if 2 CH2 groups are present between 2 acid groups, now this acid is actually succinic acid. The common name for this acid is what? Succinic acid. Succinic acid. And what will be the IUPAC name? This is first carbon, this is second carbon, third also present here itself. So 3, because CH2 twice we have written. So 2, 3, this one is what? 4. Okay, so totally 4 carbons, but only single bond. So N, 1 and 4 are carboxylic acids, 1, 4 dioic acid. 1, 4 dioic acid. If you put instead of 2 here 3, that is 3 CH2 groups between 2 acid groups, then it is called as glutaric acid. Its IUPAC name will be pentane 1, 5 dioic acid. If you write 4 means, instead of 2, if you write 4 means, totally 4, 5, 6 carbons, then its common name is adipic acid. Adipic acid. Okay, IUPAC name is hexane 1, 6 dioic acid. Okay, so butane 1, 4 dioic acid. This is malonic acid, this is succinic acid. If you increase carbon by 1, then it is glutaric acid. 1 more carbon means if you increase, then it is called as adipic acid. Okay, right, fine. Okay, so carboxylic acids, up to this it is enough, I think. Okay, now let us see the next functional group. The next functional group. What else? Aldehydes and ketones. Let us see. Aldehydes and ketones. Okay, right, fine. Okay, so this is carboxylic acids. Let them be. Now let us continue. Let us see the next functional group. The next functional group we are going to see is what? Aldehydes. Aldehydes followed by ketones. Okay. Aldehydes are the organic compounds having CHO as the functional group. With this CHO group, alkyl or any aryl group may present. Okay. In the same way, if the functional group is CHO, then it is called as aldehydes. Then, if the hydrogen atom of aldehyde group, see clearly the hydrogen atom in CHO, this H, the hydrogen atom of aldehyde group is replaced by some other alkyl or aryl group, then those compounds are called as ketones. So in ketones, the functional group is what? CO. Simply what? CO. Okay. So CHO is the functional group of aldehydes and CO is the functional group for ketones. So aldehydes and ketones. Okay. Right. Generally, the IUPAC name of aldehydes, how the names will be. So first you have to choose the root word based on the number of carbons. So it is alk. If single bonds only present means an. If double bonds are means ene. Triple means ein. So alkene, alkan, alkene, alkyne based on the type of bond. Okay. Then the IUPAC name for aldehydes, the first two letters from the aldehydes. The first two letters from the aldehydes. What? Al. Al. So alk and al, or alkene al, or alkyne al. So this is the general IUPAC name of aldehydes. In the same way, for ketones, based on the number of carbons, the root word alk is written and it is chosen. Single bonds means and double bonds means triple means ein. And for ketones, ketone, one. So the word one. So the IUPAC name ends with one, one. So simply alkanone or alkenone or alkynone. This is the general IUPAC name for ketones. Okay, let us continue. And for aldehydes, the very first aldehyde that has two carbon atoms, one carbon atom. One carbon atom is HCHO. Okay, this is the very first aldehyde. So in acids, the acid that has only one carbon atom is formic acid. Like we have HCHO. Generally, the common names of aldehydes is written from their or from the respective carboxylic acids. Okay, if you see formic acid, this compound looks like what? Formic acid. Okay, but this is an aldehyde. So the name is form. From formic acid, form is taken. Instead of ic acid, we add what? Aldehyde. Instead of ic acid, we add aldehyde. So this is formaldehyde. This is what? Formaldehyde. Okay. In the same way, the aldehyde that has two carbon atoms, CH3, CHO, we can write. Okay. Its common name is, we should not write this is methyl sir, this is aldehyde sir, this is methyl aldehyde sir. Will you write? No. This is methyl sir, CHO is aldehyde. So methyl aldehyde. No, it is wrong. Methyl aldehyde is wrong. This aldehyde looks like what? Acetic acid. Okay. This aldehyde actually forms acetic acid on oxidation. Okay. Right. So this aldehyde, its name is derived from acetic acid. So like formaldehyde, we can write what? Acid. From formic, we have taken form. In the same way here, from acetic, we have to take acid. Instead of ic acid, we add what? Aldehyde. So this is acetaldehyde. The common name for CH3CHO is what? Acetaldehyde. Okay. In the same way, the aldehyde with the three carbon atoms, CH3, CH2, CHO. So the common name is propionic acid. So what? Propionaldehyde. So the common names of aldehydes are generally taken from their respective carboxylic acids. Okay. So this is propionaldehyde. Okay. In the same way, the aldehyde with the four carbon atoms, CH3, CH2, CH2, CHO. If you are not writing bonds between carbon atoms, means that is also understood. No problem. It is considered that here bonds are present. Okay. If you are indicating the bonds, means no problem. Okay. So for this common name, if acid group is present instead of aldehyde group, then it is called as N-butyric acid. Since aldehyde group is present here, so the ic acid, ic acid is replaced by aldehyde. So this is N-butyraldehyde. N-butyraldehyde. Okay. Like aromatic. So benzene with the aldehyde. Okay. Its common name is, acid means benzoic acid. So aldehyde means benzoic acid. Up to benz we have written. Oic acid is removed. Okay. Here what? Oic acid is removed. Instead of oic acid, aldehyde. Benzaldehyde. Okay. This is the common name. Okay. So in the IUPAC name, let us see. For IUPAC, For writing of IUPAC, the root word based on the number of carbons, alk is chosen. Format it contains only one carbon. So its IUPAC name will be what? One carbon means the root word is meth plus no double bond. So and for aldehyde, the IUPAC name will end with al. So meth and al. So the IUPAC name is methanal. Formaldehyde's IUPAC name is methanal. Methanol is the IUPAC name for formaldehyde. Fine. Okay. Right. And for acetaldehyde, 2 carbons. 1, 2. So 2 carbons. The root word is eth, no double bond. So and, so al. Eth and al. Ethanol. Ethanol is different. CH3, CH2, OH. This is eth and all. Ethanol. This is ethanol. This is ethanol. You see how beautifully. Okay. Al. This is OL. For alcohols, the IUPAC name is OL. And for aldehydes, the IUPAC name is Al. If they are considered as functional group. Okay. Right. Fine. And for propanaldehyde. The IUPAC name is, what it will be? Easily you can say. Prop and al. Good. So prop and al. Okay. You have to see the name in 3 parts. Okay. Prop and al. Okay. So root word. This is for alkene part. Okay. This is the primary suffix actually. This is for functional group. Okay. Right. Prop and al. Okay. So propanol. And for N-butyraldehyde. The IUPAC name is what? 1, 2, 3, 4. 4 carbons means but. So and there is no double bond, only single bonds between carbon atoms. So and for aldehyde, al. For aldehyde group, we should not give number 1. Here also propanaldehyde. In propanaldehyde should we give 1 al, prop and 1 al? No, it is wrong. 1 al no need. Here also butane 1 al no need. Why? Because like carboxylic acids, okay, the functional group itself contains 1 carbon. Always that is the first carbon. Wherever it is, here only aldehyde group is present. So wherever it is, we have to go there and we have to give number 1 to aldehyde. Okay. Okay. So that's why no need to mention the number 1. Okay. Number 2 won't be given, cannot be given. Should not be given. Okay. Right. And for benzaldehyde. Okay. So and for benzaldehyde, the IUPAC name. Okay. In TN state board, TN board book. And for formaldehyde, the IUPAC name is what? Methanol. Okay. Instead of 1 hydrogen in methanol, this phenyl group is present. So phenyl methanol. But IUPAC name in NCERT book is benzene carbaldehyde. Like benzene carboxylic acid, this is benzene carbaldehyde. Okay, right, good. So like that, phthalic acid you have seen, So like phthalic acid, the aldehyde, if two aldehyde groups are present at an angle of 60 degree, then this compound is called as phthalaldehyde. PHTHA, phthalaldehyde. And its IUPAC name will be benzene. If 2 acyl groups are present, what we have given already? What was given? Benzene 1,2 dicarboxylic acid. So in the same way, benzene 1,2 dicarbaldehyde. Benzene 1,2 dicarbaldehyde. So for phthalaldehyde, benzene 1,2 dicarbaldehyde. In the same way, for benzaldehyde, benzene carbaldehyde simply will be the correct IUPAC name. Okay. So if your Tamil Nadu board means, then you have to follow according to your book. Okay. Right. Fine. So this is phthalaldehyde. So benzene 1,2 dicarbaldehyde. Okay. If 2 acid groups are joined, this compound was called as what? Oxalic acid. Ox means what? 2 identical. Simply I told. If the name has ox means, then it may have 2 identical groups. If it is if the two identical groups are acid groups, then it is called as oxalic acid. And if the two identical groups are aldehyde groups, then it is called as glyoxal. Glyoxal. The common name for this compound is what? Glyoxal. Glyoxal. Okay. For glyoxal, the IUPAC name is ethane diol. Ethane diol, not all. Since aldehyde is what? Al. So ethane diol. Glyoxal. So you see here also ox, the name ox has come. Okay. So al stands for acid. So here oxalic acid. Here oxal. This is oxal. This is oxalic acid. Okay. This gly is generally what? It remembers first glucose. So yeah, if you taste glucose, it is sweet in taste. Okay, right. So the word, whenever the word gly is present, it tastes sweet. So this compound also tastes as sweet. That's why the name has the word gly. So glyoxal, its IUPAC name is ethane diol. Okay. Okay. So by this, let us finish what? Aldehydes. So carboxylic acids, aldehydes. If you know carboxylic acids, then easily we can write the common name and IUPAC name of aldehydes, respective aldehydes. And let us see about ketones. There is no ketone having one carbon, and there is no ketone having two carbon atoms. The very first ketone, okay, is the one which has three carbon atoms. So C. Actually, ketone group is not the terminal functional group. It will not be present at the terminal. It will not be present at the end of the structure. Okay. Always it will be at non-terminal. Okay. Right. That's why. So C double bond. And the valency of C double bond O, ketone group is 2. Around ketone group, always there will be 2 bonds. Okay. So ketone group means 2 bonds should be there. Okay. Left and right side should have at least 2 alkyl or aryl groups of either same or different. Okay. If you have this one alkyl group, if you put hydrogen, now this group is nothing but aldehyde group, which is CHO. You see CHO. You should not put hydrogen. So 2 alkyl or 2 aryl or 1 alkyl, 1 aryl may be present. Okay. So this is the very first ketone that has 3 carbon atoms. And its common name is actually acid. Acetaldehyde has 2 carbons. Acetic acid has 2 carbons. But the very first ketone's common name starts with acid. Why acid? Means this ketone on strong oxidation forms the acid acetic acid. Since it forms acetic acid, its common name is similar to that of acetic acid, so the name starts with acid. Since it is ketone, so on acetone. It is ketone, acetone. Otherwise we can give for ketones the common name should be ending with the word ketone. Before that, 2 alkyl groups. If 2 alkyl groups are same means then dialkyl. If they are different means then you have to write separately. So alkyl ketone. If both are same means dialkyl. If they are different means you have to write the name separately. Okay, so see, this is methyl, this is also methyl. So methyl ketone. So this is dimethyl ketone. So like ethers, the common names. So dimethyl ketone. So acetone is nothing but dimethyl ketone. Okay. So acetone's IUPAC name is what? One more common name is what? Dimethyl ketone. And let us see the IUPAC name of acetone. So based on the role, we are counting the number of carbons. So 1, 2, 3. So from either side you can count. Okay. So always this ketone group should get the least possible number. So if you start from here, the group gets number 2. If you start from here also, the group gets the same number 2. So either side is correct. Okay. So the root word is 3 carbons means what? Only single bond between the carbons. You should not see this double bond. This double bond is between carbon and oxygen, which indicates ketone group. But To write an, in or ein, you should see always what? The bond between the carbon atoms. Okay, so here between the carbon atoms, the bond is what? Single. Okay, so an. Being ketone, it is on. So prep and on. Since the ketones position is 2, we should not give number 2 because you can't write the ketone group in the first position. You can't write the ketone group in the third position. Okay, always the position will be 2 only. So no need to mention the position of ketone group here. So simply propanone. Simply what? Propanone. Okay. So the very first ketone, acetone, otherwise called as dimethyl ketone, and its IUPAC name is what? Propanone. Okay. And the ketone with the 4 carbon atoms, C double bond O. You can place the ketone group either here or here. Both are identical. You see, both are identical. Okay. Isn't it? So hydrogens are filled CH3, CH2, CH3. CH3, CH2 here, CH3 here. And its common name is methyl. This is CH3, CH2. What? Ethyl. This is methyl. Methyl, ethyl or ethyl, methyl? Ethyl methyl ketone. For this compound, ethyl methyl ketone. And for this compound, methyl ethyl ketone should be right. Methyl ethyl ketone. Should be right? No, it is wrong. So we have to follow what? Alphabetical order. Okay, alphabetical order. So E comes first, followed by M. Okay, so E is always first. So you can write either this structure or this structure, but the name is what? Ethyl methyl ketone. For both these structures, these are identical actually. Okay, so ethyl methyl ketone. And IUPAC name, we have to give the numbering in such a way that ketone group should get the least possible number. Always the functional group should get the least possible number. That you should keep in your mind. Okay, so if you start from here, the ketone group gets number 2. If you start from here, 1, 2, now ketone group will get number 3. Which one is correct? 2 is correct, isn't it? Okay, so 1, 2, 3, 4. In this compound also, you have to start from here. Then only ketone will get the number 2. So 1, 2, 3, 4. So totally 4 carbons. So the root word is what? Bute. The root word is what? Bute. Since there is no double bond between carbon atoms, only single bonds are there. So an. And for ketone, so one. Should we write 2-1? Is it necessary? In this compound, you cannot change the position of ketone group into 3, into 1, into 4. You can't change. Only one position is available. Only one position will be correct. That position is number 2. If you change the position here, then also it will be number 2. So there is no other choice in this compound. So only simply butanone is enough. But in some books, butane 2-1 may also be given. But no need to give 2-1. Simply butanone is enough. Okay, right. So this is butanone. Okay, right. Now let us write the ketone with the 5 carbon atoms. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1 carbon atom branch. Okay. So ketone, C double bond O. If you change the position of ketone to here, this is another ketone. If you change the position of here, now you will get the first compound. Okay, so in these 2 structures, you can change the ketone only in 2 ways, either here or at the middle. Okay, so H3, H2, H2, H3. Here H3, H2, H2, H3. Am I right? Hydrogens are filled. Okay, so first let us give the common name. Around ketone group there will be 2 alkyl or aryl groups, so we have to name them based on the alphabetical order. So this is methyl, this is N-propyl. Methyl N-propyl. Which one should come first? Methyl or N-propyl? Methyl, M or P? M only first. Okay, you should not see what n propyl. In n propyl this n should not be considered, so m comes first, so methyl n propyl ketone, this compound methyl n propyl ketone. And for this compound what will be the IUPAC name, sorry common name, ethyl. This is also ethyl, CH3CH2, what, ethyl, CH2CH3, totally it is C2H5, this is also C2H5, so ethyl. In both sides ethyl groups are present, so diethyl ketone, diethyl ketone is the common name. Okay, and for this compound CH3, CH3, CH, CH3, here ketone group. And for this compound what will be the common name, this is methyl, this is CH with the 2 CH3, CH group with this 2 CH3 attached. This is called as what, isopropyl. Good, isopropyl, those who have said isopropyl, good. So this is isopropyl, this is methyl. So around ketone group, two different groups are there, we have to name them. So methyl followed by isopropyl, methyl only should come first in alphabetical order. So methyl isopropyl ketone, methyl isopropyl ketone, this is the common name. And let us write the IUPAC name, let us write the IUPAC name. Okay, we have to number, numbering is from this side 1 2 3 4 5. If you start from this side then ketone gets number 2, ketone gets number 2. In this compound you can start from any direction, in both directions the ketone will get the same number 3, isn't it? Okay, in this compound if you start from here ketone will get 3, and if you start from this side ketone will get 2, isn't it? Okay, fine, let us write the IUPAC names. So totally 5 carbons, so pent, only single bonds are there between the carbon atoms, so an, pent an. The position of ketone is 2, so 2 1. Should we mention the position of ketone group as number 2, 2 1? 2 1 is necessary, 2 1 is necessary, yes, you should mention, it must be mentioned, because the IUPAC name for the next compound, IUPAC name for this compound is what it will be. If you start numbering in either direction the ketone group gets the same number 3, so totally 5 carbons, the root word is pent, single bond, and for ketone 3 1. So this is pentan 3 1, this is pentan 2 1. So there are two different types of pentanones, pentan 2 1 and pentan 3 1. Pentan 2 1 is nothing but methyl n propyl ketone, pentan 3 1 is nothing but diethyl ketone. So in these two cases we have to mention the position of ketone group in IUPAC names, it is must. Okay, we have to mention. Okay, fine, let us see the IUPAC name of the last compound, methyl isopropyl ketone, methyl isopropyl ketone. If you start from here ketone gets number 2, so this is only correct. So ketone at number 2, methyl group at number 3. So in IUPAC, the first, the substituent group is written before the root word. So 3 methyl, what, 3 methyl, remaining 4 carbons, so but, single bond, so and 2 1, so 2 1, so 3 methyl butane 2 1, 3 methyl butane 2 1. Okay, if you omit this number 2 1, simply writing butanone is also correct only, because you can't change the position of ketone to anywhere in this compound. You can't change it into 3, you can't change it into 4, okay, you can't change it to anywhere. So if you are omitting this number 2 also correct. Okay, so 3 methyl butane 2 1 or simply 3 methyl butanone also correct. Okay, fine. So ketones, so for some aliphatic ketones we have written the IUPAC with the common names. Okay, now let us see about the IUPAC name of some aromatic ketones, IUPAC names and the common names of some aromatic ketones. Okay, right, fine. This is aromatic benzene COCH3, or simply we can write C6H5 C double bond O CH3. Its common name is its common name is methylphenyl ketone. Methylphenyl ketone. Methylphenyl ketone. Methylphenyl ketone. Methylphenyl ketone. Okay, right. So M first, P next, are based on alphabetical order, and its IUPAC name will be. Its IUPAC name will be special name. What? Special name. Special name. Acetophenone. Acetophenone. Acetophenone is the IUPAC name of this compound. IUPAC committee has given the IUPAC name like this, acetophenone. Okay, so this is the group acetophenyl group, ketone one, so acetophenone, like this you can write. Okay, in Tamil Nadu State Board Book, TN State Board Book, TN Board Book, in TN Board Book, one more name also. In TN Board Book also, acetophenone name has been given as a IUPAC name. One more name also, that is phenyl 2 carbons eth. So phenyl 2 carbons means eth, single bonds and so on. So phenyl ethanol. Yeah. But the first one is the preferred IUPAC name. Preferred IUPAC name, PIN. Yeah. So more often we are following the first one, acetophenone. Acetophenone. Methylphenyl ketones, IUPAC name is acetophenone. Okay, all right. Instead of methyl group, if we introduce one more phenyl group, CO C6H5, or simply we can write C6H5 C double bond O C6H5, or simply we can write benzene ring C double bond O, one more benzene ring. Okay, so all are identical. Okay, so phenyl ketone, so diphenyl ketone, phenyl ketone, diphenyl ketone, like dimethyl ketone, it is diphenyl ketone. Diphenyl or simply biphenyl, di is equal to bi means 2, di means 2, so biphenyl or diphenyl, so biphenyl ketone also correct. So biphenyl or diphenyl ketone is the common name, and the IUPAC name for this compound, IUPAC name for this compound will be, what will be? Special name. Here also the special name, benzophenone. Benzophenone is the special IUPAC name given by the IUPAC committee. So benzophenone, diphenyl ketones IUPAC name is what? Benzophenone. Benzophenone, phenone, this is benzene ring, so benzophenone, like that you can understand. Okay, and in TN board book, one more name also has been given, that is phenyl. 2 phenyl groups are there, so diphenyl. In the common name also we are given what? Diphenyl. For ketone group itself contains 1 carbon, so meth and one, diphenyl methanol. Okay, but benzophenone is the most preferred IUPAC name. So preferred IUPAC name, PIN is what? Preferred IUPAC name is benzophenone. It is the correct. Okay, diphenyl methanol is also given in the Tamil Nadu board book. Okay, right. So carboxylic acids, aldehydes, ketones. So previously I finished carboxylic acid and then derivatives. Okay, right. So organic compounds, common name, structure, IUPAC name. Understanding of all this is very, very important. Very, very important. Okay. Let us continue and finish this topic actually. IUPAC naming to monofunctional group compounds. That is our topic. Actually, we are teaching about what? Organic basics. This is some basic series actually. In basic series, we are seeing organic basics. Okay. So, organic compounds, IUPAC names, different types of groups, all you have finished. So in the continuation of organic compounds, name, structure and occupation name, let us see the next one. Let us see the next one. What? Amines. What? Amines. 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 When you pronounce the word amines, it remembers ammonia. Actually, ammonia, NH3 is the mother of amines. NH3 is the mother of what? All the amines. There are three types of amines. In ammonia, if you replace one hydrogen by one alkyl or aryl group, then you will get the R bond NH2 structure. If you remove two hydrogen atoms from the ammonia, you will get R NHR. If you remove all the three hydrogen atoms from ammonia, you will get what? R. At the middle, N. So N is surrounded by three alkyl groups. In ammonia, nitrogen has one lone pair of electrons. So like that, all the amines also have the one lone pair on the nitrogen atom. We can write. Okay. So actually there are three types of amines. Okay. Right. So what are they? This is primary amine. This is what? Primary amine. This is secondary amine. This is secondary amine. This is tertiary amine. This is tertiary amine. This is ammonia. So amines are the derivatives of ammonia. Amines are the children of ammonia. Ammonia is the mother of all the amines. Ammonia is the mother of all the amines. Okay, right? Just by seeing the structure itself, we can distinguish different types of amines, whether it is primary, secondary or tertiary. So primary, secondary or tertiary. If it is the primary amine, then in its structure NH2 group is present. If NH2 group is present, then it is what? Primary amine. If NH group is present, then it is called as what? Secondary amine. If N group is present, then it is called as what? Tertiary amine. Okay. Actually, NH2 group is simply otherwise called as amino group. NH2 group is otherwise called as amino group, whereas NH group is otherwise called as imino group. Imino group is the functional group of secondary amines, whereas amino group is the functional group of primary amines. This N is called as tertiary nitrogen atom. This tertiary nitrogen atom is the functional group of tertiary amines. Okay. So based on the structures, we can try different types of amines. Okay, so let us write CH3NH2. One more amine, CH3CH2NH2. One more amine, CH3CH2CH2NH2. One more amine, CH3CHNH2CH3. Okay, you see which type of amines these are all. Because all these contain NH2. If the amine contains NH2 group, means then it is what? Primary. All these are primary amines. So all these are primary amines. So primary. Okay, right. Okay, let us continue. Let us write some more. Okay. CH3, CH3, CH2, NH2. Is it a primary or a secondary amine? Yes, very good. This is also a primary amine because it also contains NH2 group. Okay, right. Next, CH3, CH, NH2, CH2, CH3. This one, whether primary, secondary or tertiary? Huh? Yes, this also a primary amine. This also a primary amine. Okay. CH3, C, NH2, CH3, CH3. This one also primary amine because this also contains NH2 group. This also contains what? NH2 group. Okay, right. CH3, NH, CH3. CH3, NH, CH2, CH2, CH3. This one? Yes, these two are secondary amines because these two contain NH in the structure. If the amine contains NH, imino group in its structure, then it is what? Secondary amine. Secondary amine. Okay, right. I write one more. CH3, N, CH3, CH3. This one. Very good, tertiary. Very good, tertiary, because it contains N, which is a tertiary nitrogen atom, N in its structure. So simply just by seeing the structure itself, we can simply classify the types of amines. NH2 means primary, NH means secondary, N means tertiary. N means tertiary. Okay, right. Let us give their common names. Let us give their common names. Structure followed by common name. Okay, common name is nothing but first you have to, whatever may be the amine, the common name will end with amine. Whether it is primary, secondary or tertiary, whatever may be the amine, the common name will end with what? Amine. Before the common name, before the word amine, we should write the alkyl groups, the name of alkyl groups. If the name of alkyl group. Okay. If it is primary, the structure will contain only one alkyl group. All the primary amines will contain only one alkyl group. So based on the number of alkyl groups, we can classify amines. If the alkyl group is only one, then it is primary. If there are two alkyl groups, it is secondary. If there are three alkyl groups, then it is tertiary. Not only alkyl, aryl also. Aryl maybe alkyl or aryl. Alkyl or aryl. Alkyl or aryl. Okay, right? Okay. So based on the structure, we can classify amines. Based on the number of alkyl or aryl groups, also we can classify amines. Okay, right. You see, common name for first amine, this is CH3, which is methyl group. NH2 is amine. So the name of this amine is methylamine. The name of this amine is what? Methylamine. 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 Okay. And the second one, CH3CH2. This is ethyl group. So this is ethyl amine. Ethylamine. Methylamine, ethylamine, primary because they contain only one alkyl group. Methyl, one alkyl group. Ethyl, also one alkyl group. And third one, this is N-propyl group. So the third one is N-propyl amine. The third one is N-propyl amine. And this compound, this group is isopropyl group. So this is isopropyl amine. Isopropyl amine. Isn't it? Okay. N-propylamine is a primary amine. Isopropylamine is a N-propylamine is a primary amine. Isopropylamine is also a primary amine because it also contains NH2 group. But isopropyl alcohol is a secondary alcohol. In alcohols, if the alcohol contains CHOH group, then it is called as secondary alcohol. But in amines, we are just seeing the NH2 group. Whether the group is NH2 or NH or simply N only, without considering the carbon to which the amino group is attached. Okay, right. So this is isopropyl. Isopropyl means only one alkyl group. So only one alkyl group means it is primary. This is actually what? Isobutyl. This is isobutyl. So this is isobutylamine. This is isobutylamine. Isn't it? Right. The next one is, this group is secondary butyl. This is secondary butylamines. we know we have already seen about the butyl groups. There are 4 different types of butyl groups: N-butyl, isobutyl, secondary butyl, and tertiary butyl. This is isobutyl, this is secondary butyl, so secondary butylamine. This is, you see clearly, tertiary butyl. Here instead of NH2 group, OH is present, it is tertiary butyl alcohol. But here NH2 only present, so it is tertiary butylamine. Tertiary, simply tertiary butylamine. Secondary, simply SEC dot or 2 degree. Tertiary, 3 degree. You just tell isobutylamine whether it is primary, secondary or tertiary. Primary, because NH2. Secondary butylamine, is secondary butylamine a secondary amine? No, because it also a primary amine. It is also a primary amine because NH2. Okay, tertiary butylamine. Tertiary butylamine, is it a tertiary amine? No. Tertiary butylamine is also a primary amine because it also contains NH2 group. Okay, isobutyl alcohol, primary alcohol. Isobutylamine, primary amine, no problem. Secondary butyl alcohol is a secondary alcohol, whereas secondary butylamine is a primary amine. Okay, in case of alcohols, if the alcohol has CH2OH means it is primary. If it has CHOH means it is secondary. If it has COH means it is tertiary. We are not only simply considering what OH group, we are considering both OH and the attached carbon atom. Both together we are considering CH2OH, CHOH, COH in alcohols. But the amines, just the amino group, whether it is NH2, NH or N. All are amino group, all are amines, but their name may be different. This is amino, this is imino, this is tertiary nitrogen atom. So see, secondary butylamine is a primary amine, tertiary butylamine is also a primary amine because both contain NH2. So all these amines are primary only because all these contain NH2 as the functional group. Okay, right. This is secondary amine. So methylamine. So dimethylamine. So methylamine. So dimethylamine. You see clearly, dimethylamine. Methylamine. This is N-propyl, this is methyl. Methyl N-propylamine. Alphabetical order. Methyl N-propylamine. Methyl N-propylamine. Okay, this is methylamine. Trimethylamine. You see, dimethylamine, methyl N-propylamine. These two are secondary amines because they contain NH as the functional group. You see, in common name also, if there are 2 alkyl groups are present, then it is a secondary amine. 2 alkyl groups. Like that, methyl N-propyl. Methyl group and N-propyl group. So, the common name itself shows 2 alkyl groups. Okay. So, these two are secondary amines. So, secondary amines will have generally 2 alkyl groups. What about tertiary? Tertiary amines will have 3 alkyl groups. You see, this is methyl. In the structure, it is clear that this compound has 3 alkyl groups. Methyl. So, it is a tertiary amine. Okay. In the common name also, trimethyl. Tri means 3 methyl groups. It shows what? It stands for what? 3 methyl groups. So, it is a tertiary amine. It is a tertiary amines. Okay. Okay, fine. Now, let us write their IUPAC names. IUPAC names. So, IUPAC names for these different types of amines. Okay, let us see. Generally, the IUPAC name, how it will be, we have to choose the root word. Generally, the root word is alk. That alk name is taken from the number of carbon atoms. Okay, if it has only 1 carbon, meth. 2 means eth. 3 means prop, but, pent, like that it goes on. Okay, and if only single bond means an, between carbon and carbon, between carbon, if there is only single bonds means an. If any double bond present between carbon atoms, then it is ene, alkene. An, alkene and alkyne. So, an, ene, ine. Okay. Then the IUPAC name for primary amine, secondary amine and tertiary amine. For all these three types of amines, the IUPAC name will be amine. The word amine, A-M-I-N-E, amine. So the general IUPAC name for all the three types of amines is what? Alk-an amine, or alkene amine, or alkyne amine. Okay. So alk and amine will not change. If the single bond only present, and double bond means ene, triple bond means ine. Alkene, alkane, alkyne. Okay, amine. Right, fine. Okay, let us write the IUPAC name for the first one, which is methylamine. So it has only one carbon. So the root word is meth, no double bond. So and NH2. IUPAC name is what? Amine. Whether it is primary, secondary or tertiary, for all these three types, the IUPAC name is what? Amine only. Amine. Okay, right. What about ethylamine? It has two carbon atoms. So the root word is eth. The root word is what? Eth. There is no double bond, only single bond present. So an. So it is saturated. So an. Only single bond. So an. And for NH2, the IUPAC name is what? Amine. Okay, so eth and amine. Ethanamine. You have to divide this name into three parts. Eth, root word, and whether for saturated or unsaturated. It is for saturated or unsaturated. Single bond means saturated. Double or triple bonds means unsaturated. Okay, so an, ene, ine. So for this case, it is an, and IUPAC name for NH2 group is amine. So eth and amine, meth and amine, eth and amine. Okay. The next compound, N-propylamine. The common name is N-propylamine. If propyl comes, we have to focus on the position of the functional group also. In N-propylamine, the NH2 group is attached with the first carbon. NH2 group is attached with the first carbon. So there are totally 3 carbon atoms in the chain. So 3 carbons means the root word is prop. 3 carbons. The root word is what? Prop. Okay. Only single bond. So an. Then for NH2 it is amine. Since NH2 group is attached with the first carbon, so it is one amine. So propan, one amine. Propan, one amine. Okay, propan, one amine. And what about isopropylamine? In the same way, in isopropylamine, NH2 group is attached with the middle carbon, which is carbon number 2. So there are 3 carbons in the chain. So the root word is prop. There is no double bond, only single bonds are present. So and NH2 group, its position is 2. So propan 2 amine. Propan 1 amine is N-propylamine. Propan 2 amine is isopropylamine. Okay, right, fine. And what about isobutylamine? Isobutylamine is also a primary amine because it contains NH2 group in its structure and it has only one alkyl group, that is isobutyl group. So it is primary. Okay, so we have to give numbers. So NH2 group should get the least possible number. So number 1 from here. So 1, 2, 3. So there are 3 carbons in the continuous longest carbon chain. So in this, at the second carbon, one methyl group is attached, and at first carbon, NH2 group is attached. Okay, right. So let us write the IUPAC name. At the second carbon, methyl group is attached. So 2-methyl. So what? 2-methyl. Okay. So the longest carbon chain has 3 carbons. So the root word is prop. Only single bond. So an, propan. NH2 position is number 1. So 1 amine. So 2-methyl propan 1 amine. 2-methyl propan 1 amine. For isobutylamine, the IUPAC name is what? 2-methyl propan 1 amine. Right. What about secondary butylamine? We have to give numbers. You know very well. Always the functional group should get the lowest or least possible number. Okay. So if you start from number 1 here, from here, you will then NH2 group will get number 3. If you start from here, then the NH2 group will get number 2. Actually, which one is correct? Number 2 is correct. Okay. So in the chain, there are 4 carbon atoms. So the root word is but. Only single bond. So an, but an. Second carbon has NH2 groups. So what? 2 amine. So butane 2 amine. For secondary butylamine, the IUPAC name is butane 2 amine. Secondary butylamine is also a primary amine because it contains NH2 in its structure and only one alkyl group in the structure as well as in the common name. Okay, fine. What about tertiary butylamine? You say tertiary butylamine is it primary, secondary or tertiary? Tertiary butylamine is a primary amine. Good. It is a primary amine, not tertiary amine because in its structure it has NH2 group. If the amine has NH2 group in its structure, then it is primary. If the amine in its common name, if it has only one alkyl group, then it is primary. So tertiary butyl itself is only one alkyl group. So it is what? Primary. Okay, so we have to give IUPAC name. So numbering the carbon chain. If you start from here, this side the chain will have only 2 carbon atoms. It is wrong actually. So if you start either from bottom to top or top to bottom, you will get 3 carbons in the chain. Okay, both are correct. Either from top to bottom or bottom to top. So there are 3 carbons in the chain. Second carbon has both methyl group as well as NH2 group. Okay, so second carbon has methyl group. So 2 methyl, 2 hyphen methyl, 2 hyphen methyl, 2 methyl. The chain has 3 carbons. So root word is what? Prop. That is not double bond. So an. The second carbon has the functional group amine. So 2 methyl propan 2 amine. The IUPAC name for tertiary butylamine is what? 2 methyl propan 2 amine. What about 2 methyl propan 1 amine? 2 methyl propan 1 amine is isobutylamine. 2 methyl propan 2 amine is tertiary butylamine. Both are primary amines. Okay, and they are isomers also. What type of isomers they will be? Because in isobutylamine it ends with 1 amine. Tertiary butylamine ends with 2 amine. So the position of functional group changes. Both have same primary amine as the functional group, but the position changes. So they are position isomers. Okay, fine. Let us enter into the next type of amines. So we have finished primary amines structure, common name and IUPAC name. Okay, if you understand this, then you can write the name of any type of primary amine. Okay, fine. Now let us move into secondary amines. The first one we have written here is dimethylamine. You see, like ethers, secondary amines also have 2 alkyl group in the structure. In ethers, between 2 alkyl groups or 2 aryl groups or 1 alkyl, 1 aryl group, O is present, but here instead of O, NH group, imino group is present. Imino group is the functional group of secondary amines. Okay, right. So like ethers, here also we have to choose the one of the 2 alkyl groups. That alkyl group should have more number of carbon atoms. That is the larger alkyl group we have to choose. That larger alkyl group should end with the alkane name. Should end as alkane. Okay, but in dimethylamine there is no problem because before and after NH group only methyl groups are present. So you can take any one methyl group as the chain. Okay, so I take this one. This is methyl group. It has only 1 carbon. So 1 carbon, the alkane is what? Methane. The alkane part is methane. Okay, in methane, this CH3NH group is attached. Like that we have to consider. With methane, instead of 1 hydrogen, this CH3NH group is attached. Okay, so CH3 is methyl. That methyl group is attached with the nitrogen. So N-methyl. For NH, the IUPAC name is what? Amine. Okay, for NH, the IUPAC name is what? Amine. So the root word is meth. In this methyl part, which is taken as alkane, there is no double bond. So and meth and for NH, the IUPAC name is what? Amine. So N-methyl methanamine. You see, with nitrogen, 1 methyl is attached. The remaining part has 1 carbon. So meth, no double bond, and for NH, the IUPAC name is amine. So methanamine. So N-methyl methanamine. Understood? Okay, fine. And what about methyl N-propylamine? Methyl N-propylamine, this one. You see, which is the larger alkyl group? N-propyl. So N-propyl is the largest alkyl group in this case. So with this largest alkyl group N-propyl, this CH3NH is attached. So this largest alkyl group should end as alkane. It has 3 carbons and it is named. Numbering should be given in such a way that the functional group should get the lowest possible number, isn't it? So with this first carbon, NH is attached. So this is N-propyl part. It has 3 carbons. So yeah, the root word is prop. The root word is what? Prop. Okay. There is no double bond in N-propyl part. So an. Okay. With propan in the first carbon, what is attached? CH3NH is attached. For CH3NH, what we should write? N-methyl. That N should be written as such. N-methyl. So, with propan in the first carbon, N-methyl is attached. So, propan, and for NH, the IUPAC name is what? Amine. Okay. So, N-methyl, you see, we should write clearly. This is 3 carbons. So, the root word is prop. There is no double bond. So, an. So, propan. With the first carbon, NH is attached. So, 1 amine. What? 1 amine. Okay. Alright. With N, with this NH, 1 methyl is also attached. That should be written at first. So, N-methyl. N-methyl propan 1 amine. N-methyl propan 1 amine. Isn't it clear? N-methyl propan 1 amine. So for secondary amines, we have to give the names, IUPAC names like this. You see, in the case of secondary amines, the IUPAC name always will have capital N. It starts with capital N. In the common name, the secondary amines will have 2 alkyl groups. Like that, in their IUPAC name, the secondary amines will have capital N, which indicates what? Nitrogen. That nitrogen will have 1 alkyl group. So it starts with N-alkyl, N-alkyl. In these 2 cases, N-methyl, N-methyl. If the IUPAC name starts with N-alkyl, definitely it will be what? Secondary amine. Okay, right. What about tertiary amine? Let us see. This is trimethylamine. This is what? Trimethylamine. So in this case also, we have to follow same method of secondary amines. So around nitrogen, there are 3 alkyl groups. In this case, all are identical, all are same methyl groups. Okay. Among these 3, if they are different, the largest alkyl group should be chosen. That should end with as alkane. End as alkane. Okay. In this case, no problem, all are methyl. So I take any one methyl, I take this methyl. Okay, so that is the root word I have taken. So for 1 carbon, I have taken meth. Then no double bond, so an. And for N, the IUPAC name is what? Amine. So methanamine. CH3N, this part is what? Methanamine. In methanamine, with N, 2 methyl groups are attached. With N, 2 methyl groups are attached. With N, 1 methyl. With the same N, 1 more methyl. So N, N hyphen dimethyl. N, N hyphen dimethyl methanamine. N, N methyl. N, N dimethyl methanamine. That is IUPAC name for this trimethyl amine. Isn't it? Okay, understood? Right. If here, instead of this methyl, if ethyl is present, then what? N dimethyl ethanamine. N dimethyl ethanamine. Okay, like that we can write for other tertiary amines also. Okay, if you see the IUPAC name of this one, it is clear that the tertiary amines have N, N in their IUPAC name. N, N in their IUPAC name. You see, N, N. If the IUPAC name has N comma N, if it starts with N comma N dialkyl, N comma N dialkyl, it is tertiary. If it starts with N hyphen alkyl, it is secondary. If there is no capital N in the IUPAC name, you see here, in primary cases, there is no capital N, which indicates nitrogen. There is no capital N, so definitely it is what? Primary. So primary amines don't have capital N in their IUPAC name. Secondary amines have N alkyl, N hyphen alkyl in their IUPAC name. Tertiary amines will have N comma N dialkyl in their IUPAC name. Okay. So this IUPAC part also can be included in this table. Okay. So I write IUPAC name. By using IUPAC name, we can identify all the three types of amines. If the IUPAC name doesn't have any capital N, then it is primary. If the IUPAC name has capital N, it is secondary. If the IUPAC name starts with capital N comma N, it is tertiary. If there is no capital N, primary. If there is N hyphen N, if it starts with the N, it is secondary. N comma N means tertiary. Easily you can identify. This table is most important. Okay, just by seeing the structure or by knowing the number of alkyl groups or aryl groups in the structure, in the common name, and by knowing the IUPAC name itself, we can clearly identify the type of amines. Okay, right. Now let us write some aromatic amines also. These are all aliphatic amines. Now let us write few aromatic amines also. I write one amine. This is benzene ring. Instead of one hydrogen, NH2 group is present. Okay, so this is phenyl group. Then this is amine. So this is phenylamine. This is what? Phenylamine. Phenylamine is otherwise famously called as aniline. It is otherwise famously called as what? Aniline. Okay. The IUPAC name for aniline or phenylamine is, this is benzene with amino group. It is a primary amine. So benzene with amine, benzenamine. Instead of E, we are adding amine, the word amine. So benzenamine. Okay, right? Okay. In aniline, if you had one methyl group at ortho position, so this is orthomethyl aniline. It is orthomethyl aniline. Methyl anilines are otherwise simply called as toluenes. What? Toluenes. So it is a toluene. Since two groups are at a 60-degree angle, then it is ortho. So this is orthotoluene. So like orthotoluene, meta, para toluenes are also present. Okay. So this compound is orthotoluene. The other name is orthomethylanilin. And the IUPAC name is, since NH2 being a functional group, the number one should be started here. So this is number one and this is number two. So 2-methyl-aniline. The special name aniline itself can be given in the IUPAC name. Otherwise, we can write 2-methyl. For aniline, the IUPAC name already given was what? Benzenamine. So 2-methyl-benzenamine is also okay. 2-methyl-benzenamine is also okay. Right? Okay. So this is aniline and this is orthotoluene. Okay. Right. In aniline, I write one more compound. So toluenes are primary amines, aniline is also a primary amine. Okay, right, fine. So let us write this compound. Benzene ring with instead of one hydrogen, CH2NH2 group, or simply we can write C6H5CH2NH2. Both are same only. Right. So already we know that benzene ring along with the CH2 group is called as benzyl. C6H5CH2 is called as what? Benzyl. NH2 is what? Amine. So this is benzylamine. This is what? Benzylamine. Benzylamine is also a primary amine. It is an example of alkyl amine. Aromatic as well as aliphatic. So alkyl NH2 amine. It is also a primary amine. And what will be the IUPAC name for this compound? Okay. So since NH2 group being a functional group, it is attached with the aliphatic part. So this should be given priority. With this CH2, both NH2 group as well as phenyl groups are attached. So this is phenyl group. It should be written as such. So phenyl, CH2. It has only one carbon. So the root word is meth. So an amine. So phenyl methanamine. Phenyl methanamine is the IUPAC name for what? Benzylamine. What? Benzylamine. Okay. So like this we can write. Okay, right. So benzylamine and toluenes have same molecular formula. You see, this toluene can be written as C6H4NH2CH3. Totally, how many carbons? So 7. How many hydrogens? 4, 7, 9. So H9 and 1 N. For this benzylamine also C7H9N. C7H9N, C7H9N. Okay. So both are having the same molecular formula and they are what? Isomers. Okay, right. So aromatic part. In aromatic also we have written some amines which are of primary because they contain NH2 group. And let us write some secondary amines in aromatic also. C6H5NHCH3. It is a secondary amine. So this is N-methylaniline. Okay, or methylphenylamine. Okay, in terms of aniline, if it is NH2, it is aniline. Instead of one hydrogen, methyl is present. That methyl is with NH. So N-methyl aniline or methylphenylamine. Okay, right. So and we write IUPAC name like other secondary amines. For this also we can write. Okay, right. What we should write? The N-methyl itself, N-methyl aniline itself is the IUPAC name. Can we write? Okay. With NH, both methyl and C6H5 both are present. Okay. So N-methyl aniline itself can be given as IUPAC name. And for aniline, the IUPAC name is benzenamine. So we can write N-methyl benzenamine. N-methyl benzenamine. This also can be given as IUPAC. Since the IUPAC has capital N, it starts with capital N, it must be a secondary amine. N-methyl benzenamine. Okay, fine. And we can write what? Tertiary amines also. Right, C6H5N, C6H5. So around one nitrogen atom, around one tertiary nitrogen atom, there are 3 phenyl groups. So common name is triphenylamine. Triphenylamine is a tertiary amine because it has 3 groups. Aryl or alkyl. Okay, in this case it is aryl. So 3 alkyl groups or 3 aryl groups means it is what? Tertiary. So triphenylamine. Okay, and IUPAC name? All are phenyl groups. So for phenyl it is like what? Benzene, and for N it is amine. So benzenamine. With benzenamine, with the nitrogen atoms, 2 phenyl groups are present. So N diphenyl benzenamine. N, diphenyl benzenamine. So like trimethylamine, it is triphenylamine. For trimethylamine, the IUPAC name what we have given? N, dimethyl methanamine. The same way, here we have given what? N, diphenyl benzenamine. Isn't it? Right. So this are all what? This is tertiary and this is secondary. As we know already that secondary amines in their IUPAC will have capital N. Tertiary amines will have capital N, N. If it starts with N, N, it is tertiary. If the IUPAC name starts with capital N means it is secondary. So it satisfies our concept, our rule, isn't it? Okay, fine. So amines IUPAC names we have finished. So structure, common name and IUPAC name we have finished. Okay, right. Okay, amines over. What else? What are the remaining functional groups we have to see means let us see about nitro compounds. Okay, nitro compounds. Nitro compounds. If you know the structure of primary amines, in primary amines, the NH2 group is replaced by NO2 group. The NH2 group is replaced by NO2 group. NH2 group replaced by NO2. O2. NO2. 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 So the organic compounds that have NO2 as the functional group, they are called as what? Nitro compounds. They are called as what? Nitro compounds. Okay, if the compound has NO2 as the functional group, then they are called as nitro. Nitro. If they are having ONO, means they are called as nitrite. ONO means what? Nitrite. ONO. For example, CH3NO2 and CH3ONO. Both seem to be similar, but they are different. Here NO2, here nitrogen, with nitrogen carbon is attached, but in this case with oxygen only this carbon is attached. So the linkage is different. The linkage is different. Here with carbon, in nitro compounds with carbon N is attached. In nitrate compounds with carbon O is attached. Both seem to be similar, but they are different. But they are different functional group also. Okay, right. Okay, I write this nitrite here, CH3NO2, CH3ONO. Okay, one more interesting thing. What is that? Nitro compounds have only IUPAC name. Nitro compounds have only IUPAC name. The IUPAC name will start with nitro and end with alkane. If it is aliphatic, it ends with alkane. That is the IUPAC name of nitro compounds. There is no common name for nitro compounds. There is no common name for nitro compounds. In the same way, nitrites are having only common name. Nitrites are having only common name. The name will start with alkyl and end with nitrite. So alkyl nitrite. If it is aliphatic, it is what? Alkyl nitrite. And there is no IUPAC name for nitrites. Interesting, isn't it? Okay, right. So for nitro compounds, only IUPAC name. And for nitrites, only common name. Okay. So CH3NO2. For NO2, the IUPAC name is nitro and one carbon. So the alkane part is meth. So N. So nitromethane. And CH3NO is what? Only common name. So CH3 methyl ONO is nitrite. So methyl nitrite. Nitrates have only common name. Nitro compounds have only IUPAC name. Isn't it? Okay. Like that for here, for this compound NO2 group is present. So this is nitro and two carbons, eth, only single bond, N. So nitroethane. And for their compound, 1 nitropropane. Am I right? 1 nitropropane. This one, 2 nitropropane. 2-nitropropane. 2 nitropropane. And for this one, 2 methyl, you see, 2 methyl, 1 nitro, 2 methyl, 1 nitropropane, 2 methyl, 1 nitropropane. Okay. And for this compound, 2 nitrobutane. Am I right? 2 nitrobutane. NO2 group is the terminal functional group. Always it will have only one bond. its valency is always 1. It will be attached with the carbon chain through a single bond. Okay, so this is 2-nitrobutane. And what about this compound? 2-methyl, 2-methyl, 2-nitro, 2-methyl, 2-nitropropane, 2-methyl, 2-nitropropane, 2-methyl, 2-nitropropane. Okay, so these are all nitro compounds. These are all their respective IUPAC names. Sir, what about primary, secondary and tertiary, sir, in nitro compounds? If the nitro compound has NO2, with NO2 group, if there is CH2, that is alpha carbon, this is alpha carbon and there are 2 alpha hydrogens, means it is primary. It is what? Primary. Okay, and this is CH2NO2, so it is also primary. This is CHNO2. CHNO2 means it is what? Secondary. Secondary. Like alcohols. If the alcohol has CH2OH in its structure, it is primary, no? Alpha carbon and 2 alpha hydrogens. So primary, like that. In nitro compounds also same as that of alcohols. If the nitro compound has 2 alpha hydrogens, if you see, the structure will have CH2NO2 as overall. If it has CH2NO2, okay. So nitro compounds. Nitro compounds. Nitro compounds, if the structure as CH2NO2, then it is primary. If it has CHNO2, it is secondary. If it has CNO2, it is tertiary, like that of alcohols. Okay. So this has CHNO2, it is secondary. And what about this compound? CH2NO2, so primary. CHNO2. CH2NO2 primary, CHNO2 secondary. Secondary, 2 degree. CNO2 tertiary. 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 Instead of NO2 group, if you add ONO, if NO2 is replaced by ONO, they are called as what? Nitrites. Nitrites. So nitro compounds and nitrites are actually isomers, having same molecular formula, and there is a difference in the nature of functional group. Functional group itself differs. So they are isomers. What type of isomers? Functional isomers. We will see about isomerism later. Okay, right. So nitro compounds, and they have only IUPAC names. Nitrites are functional isomers of nitro compounds. They have only common names. Okay. Okay, fine. So up to this, IUPAC naming is over. Okay. So you have to study and practice and practice again and again. You have to write the structures, common names and IUPAC names. If you do this practice for 1 week or 10 days, then you will become very strong in organic. You will be very strong fundamentally in organic. If you strong fundamentally, then you will be healthy mentally. Fundamentally becomes mentally. Okay. Then you can play in the ground of organic. Whatever may be the compound given, you can say the structure, you can write the structure, you can say the common name, you can write the IUPAC name, everything. Based on this, you can understand all type of equations, all type of reactions in organic very well. Then you will become a specialist in organic. Want to become a specialist in organic chemistry? Yes. Yes? Yes. Then you have to watch these classes regularly and with the utmost concentration, and you have to do the practice also. Then you can become a specialist in organic. Okay. So all the best. Thank you.